Dear students, today we will start RC phase shift oscillator based on BJT. And first of all, we will derive frequency of oscillation for RC phase shift oscillator. Here we have a general structure of RC phase shift oscillator. BJT is used as basic amplifier and combination of RC network is used as feedback network. So what is first of all, what is the basic concept of safety? There are two criteria. First one is the magnitude of A beta is 1 and phase of this is 0 degree or 360. Means total phase shift around the closed loop is 360 or 0. So basic structure is, since suppose we are using single network, here you are applying an input and this is the output, then what is the value? Suppose you are applying input here. Suppose Vi is Vm sin omega t. Then suppose current is I, then what is impedance of this network? What is current of this? So impedance is given by simply R minus Jx. And voltage drop, suppose current is given by what is current? Current is Vm upon root 2, phase is 0, I upon Z. So magnitude of Z into phase. So phase is here minus pi because Z is a complex number and phase of this is, suppose phase of this is phi, then tan phi is given by minus xc upon. So phi is a negative number. So we can write I is magnitude of I into phase is positive. So this is the, since phase is positive, therefore output is simply I into R. So this is the phase lead network. Why? Because current is leading and current is leading in phase by voltage, input voltage, therefore output voltage is also leading. So if total phase shift is provided by three combination of RC network and we can select value of R and C. So one network provides 60 degree phase shift, similarly for other network also provides 60 degree. So all three networks provide total 180 degree phase shift. So this is the basic concept of phase shifting. One combination of RC network provides some 60 degree phase shift. One thing more here. Here in last step we are not using R. Instead we are using R3 because here we have input resistance and combination of R3 with Ri provides R. So we select value of R3 such that when it is added to input resistance, it provides R. So this is the basic network. Now to derive frequency of oscillation, we will draw equivalent circuit. From this network, next step is AC equivalent circuit. AC equivalent circuit for RC phase shift oscillator using BJT. So next step is, so in equivalent circuit, BJT is replaced by its model, hybrid pi model. Here we have a current source, dependent current source, which depends upon the input current. So this is the HFE IB. Here current is IB. RC. Then we have three networks, combination of three RC networks. First one, second one, and third. And in this last step, we have combination of two resistances. One is R3, another is input resistance, which is HIE. So this is the AC equivalent circuit using hybrid model. One more modification is there. Suppose we have to replace this current source into voltage source, because this current source in parallel with a resistance, when converted into voltage source, this is another equivalent circuit. We have convert this into a voltage source, RC with a voltage source here. This parallel resistance, and we have three combination of RC, CR, then again CR, then again C. You can write here, this is R3 plus HI. This is R3 HI, CR, and here we are using HI. Obviously this current is input current, that is base current. This is the base, this is the emitter, which is rounded. Obviously this is the collector, and suppose we are selecting three loop currents, I1, I2 and I3. These are three loop currents. Then to derive frequency of oscillation, we will use this network. So this is the final equivalent circuit. So from given circuit, we have to write this. Now apply KVL. Applying KVL. Applying KVL. In loop 1 or first loop. So this is the loop difference direction. We have to write so I1 into R plus RC plus 1 upon CR SC, and this is opposite, so minus I2 R. This must be equal to, and this is the current voltage source. Value of this voltage source is, here voltage source value is HFE RC into I. So this is, since reference direction is opposite, this voltage source polarity is plus minus, and this is opposing this current. So we are selecting clockwise current, and this dependent voltage source is opposing this current. So we have minus HFE RCI. So this is the first one. Now for second one, in loop 2, for second loop, you have to write minus I1 R plus 2R plus 1 upon SC I2, and I3 is opposite, so minus RI3, this must be equal to 0. This is second. And for third loop, in loop 3, apply KVL. So this is minus I2R plus, combination of this all current is, total impedance in this third loop is R plus R3. You can select R3 plus HI. This is R3 plus HI equals R. So you can directly write here. This is R2R. You can replace this value R3 and HI. Combination of R3 and HI is simply R. So you can write here R. So this is 2R plus 1 upon S into I3, and this is also 0. So these are 3 loop equations for these 3 loops. Now what is the basic thing is, we have to find out loop gain. Finally we have to find out this I3 upon IB. We have to find out this, since this is the loop gain, output upon input. I3 is the final output, IB is the input. To calculate this from these three equations, now we have an assumption, let alpha equals 1 upon omega RC, and another assumption is this ratio RC upon R is a constant. So you have to assume this. Now from this assumption, finally we have to find out. So from equation 3, you can, from equation 3, calculate I2 in terms of I3. Then from equation 2, we can find out I1 in terms of I3. So first find I2 in terms of I3 from third equation. Then I1 in terms of I3, and replace values of I1 and I2 in this equation in terms of I3. Then we will get this ratio. Finally, we have to find out this I3 upon I V. So procedure is, first from equation 3 find I2 in terms of I3. This is first step. So you can write from here. I am directly writing I2 is I3 2 minus J alpha. You can solve this equation, third one, and you will get this I2 in terms of I3. Suppose this is 4. And from equation 2, find I1 in terms of I3. So you can replace this value I2 first, then you can calculate value of I1. So from this I am directly writing I1 comes out to be I3 3 minus alpha square minus J4 alpha. So this is equation number. You can check these two values. We are simply calculating I2 from this in terms of I3, and after replacing this value of I2 in this equation, we can calculate I1 in terms of I3. So I1 in terms of I3 is this, and you have to use these values. Alpha equals 1 upon omega C, and obviously this value is S equals J omega. Now replace these two values, value of I2 and I1, in equation 1. You will get a relation between I3 and I2, and from there we can calculate ratio of I3 and I2. So now place these values. Put values of I1 and I2 from equation 4 and 5 into equation 1. Then you have a relation in just I am writing directly. This is a assignment for you. After replacing, we can find this value minus HFE K 1 plus 3K minus 5 plus K alpha square minus this 6 plus 4K alpha minus alpha cube. So actually this is an assignment for you. You can put these two values I2 and I1 in this equation in terms of I3 and solve for this ratio I3 upon I. So you will get this relation. So this is the assignment for you. You have to solve this value, then you will get this. Obviously, we are separating the real part and imaginary part. This second term is the imaginary part, first one is the real. So from this equation, we will derive frequency of oscillation. So this is the final equation. Actually, this term is the loop gain because I3 is the output current, this is the output current, and this is the input. So this is the loop gain. So loop gain is this, and this loop gain must be a real quantity to satisfy the Barkhausen criteria. And for this quantity to be a real one, obviously imaginary part of this must be 0. So you can write here again, as loop gain is a real quantity, imaginary part, this must be 0. It means 6 plus 4K into alpha minus alpha cube, this must be 0. And from here we can calculate value of alpha, and this implies alpha square equals 6 plus 4K, or alpha is, you can replace this value of alpha, then alpha is under root 6 plus 4K, and since quantity which we are using is given by, since alpha is 1 upon omega RC, this is the alpha. So you can write this is 6 plus 4K from here. Value of alpha is 1 upon omega RC. So this is the value, and from here you can get frequency of oscillation. This implies 1 upon omega 2 by f naught RC equals under root 6 plus 4. This implies f naught equals 1 upon 2 by RC under root 6 plus 4k. And this is the expression for frequency of oscillation. So this is the method or procedure to find out the frequency of oscillation for RC phase shift oscillator using BJT. So first you have to draw a circuit of RC phase shift oscillator, then draw AC equivalent circuit, then final AC equivalent circuit, then apply loop equations for 3 loops, then you will get relations for currents. Finally, you have to find out ratio of output current to input current, and from there we will derive frequency of oscillation. One thing is more, what is the condition of oscillation? This is the frequency of oscillation, and condition of oscillation, because imaginary part is 0, and when we put this value, that is imaginary part equal to 0, then we will get the condition. So at this frequency means frequency of oscillation, at oscillating frequency imaginary part is 0, it means ratio of current is simply minus HFEK divided by only real part 3k 5 plus k into 6 plus 4. Another part was there, imaginary part, that is removed. So at this frequency, this is means at oscillating frequency, this is the value of current, and from this here we can find out condition. So next, after solving, you will get, again this is assignment for you, you can solve and check. This is HFEK whole divided by 4k square 23k plus 29. You can solve and check this. For sustained oscillation, condition is this: I3 upon IB, this must be greater than 1. This must be greater than 1. And from here, if this is greater than 1, this is the basic condition, means HFE, then you can solve this. This is greater than 4k plus 23 plus 29 upon k. This is important condition on HFE. This is condition transistor parameter. When you will put this value, you will get this. And you can solve this. The value of K for having this minimum, the value of K for HFE minimum, what is the value of K for HFE to be minimum? Obviously, you know condition of maximum minimum, derivative of this with respect to K, this must be 0 for having maximum or minimum. Derivative this must be 0, and derivative of this with respect to K is 4 minus 29 upon K square. Okay, when you will differentiate this with respect to K, here 4K becomes 4, this is 0, and 29 upon K gives you minus 29 upon K square. So from here you can solve this value of K. 4 minus 29 upon K square, this is 0, or from here you can solve and check, you will get this is 2.7. So this is the value of K for minimum value of HFE. And at this value of K, you can also calculate minimum value of HFE from this relation. HFE must be greater than this, and minimum value of HFE is at this value, K equals 2.7. You can put this value K equals 2.7 and you will get HFE minimum equals, after solving you will get 44.5. You can also check this from here. K equals 2.7. If you will put this value K equals 2.7, you will get the minimum value of it. So this is all about derivation of frequency of oscillation and conditions on HFE, condition on K. So what are these values? So this is all about RC phase shift oscillator using BAT. You can note one question here. You can prepare this question because frequency of oscillation of all oscillators are important from examination point of view. You can note question. Draw the circuit of RC phase shift oscillator using BDT and derive expression for frequency of oscillation. Frequency of oscillation using hybrid model. VGT. Also find condition on HFE for oscillation. So this is all about for today. Okay, thank you. I assume you will try for this question. Okay, thank you.